All right, welcome to The Explainer. Today, we're diving into one of the most powerful, most fundamental concepts in all of modern AI, embeddings. You could say they're the secret sauce that lets machines understand the meaning behind our words. So, how do you actually teach a computer about the nuances of human language? Let's get into it. So, let's kick things off with this simple question, almost like a puzzle. You and I, we just know that king and queen are related concepts, right? They're both royalty. And we also know they have pretty much nothing in common with the word apple. But how does a computer, a machine that only thinks in numbers, figure that out? That question right there is the exact problem that embeddings were created to solve. And here is the solution. It's called an embedding. At its core, an embedding is just a list of numbers, what we call a vector, that represents something, like a word. But here's the key. It's not just a random list of numbers. It's a very carefully crafted vector created by a neural network to capture the essence, the context, the actual semantic meaning of that word. I think the best way to wrap your head around this is to picture a giant, multi-dimensional map of words. On this map, every single word is its own city. And words with similar meanings, like king and queen, well, they're placed really close to each other, like neighboring towns. Words with totally different meanings, like king and apple, they are on opposite ends of the map. The key idea is this: proximity equals similarity. And this table here really shows you how that map gets laid out. You've got king and queen as neighbors in the royalty district. You've got apple and banana hanging out together over in the fruit district. But the distance between those two districts, it's huge. And the model learns all these relationships just by analyzing billions and billions of sentences and seeing which words tend to show up together. You know, this whole concept of a meaning map was a massive, massive breakthrough. And to really appreciate why it was such a big deal, it helps to see the really clumsy way computers used to handle words before this. The old way was something called one-hot encoding. So imagine a dictionary with, say, 10,000 words. The word cat would be a list of 10,000 zeros with just a single one at its specific position. Dog would have a 1 in a different spot. But mathematically, this meant the vector for cat was just as far apart from dog as it was from democracy. All the nuance, all the context was just gone. Embeddings changed everything by putting all the words into a shared space where their relationships actually mean something. Okay, and this is where it gets really mind-bending. Because embeddings turn concepts into numbers, we can actually start to do math with them. And this is how AI starts to develop something that looks a whole lot like intuition. Now, this all works because of a really elegant linguistic idea from all the way back in 1957. It's called the distributional hypothesis. And it basically says that words that show up in similar contexts tend to have similar meanings. By looking at tons of text, an AI model learns that king and queen often show up in sentences with words like throne or palace or ruled. That's how it builds its map. And this equation, this is the beautiful result of all that learning. This is probably the most famous example of this meaning math. If you take the vector for king, then subtract the vector for man, and then add the vector for woman, the vector you end up with is incredibly close to the vector for queen. The AI has actually learned the concept of gender just from the context of words. So how does that actually work? Well, let's work through it. You start at the coordinate for king on our map. When you subtract man, it's like you're taking a step in a direction that removes all the concepts associated with maleness. Then you add woman, which is like taking a step in the direction that adds femaleness. And where do you end up? Bam, right next to queen. It's incredible. And this works for all kinds of analogies, not just gender. Now, this is way more than just a cool party trick. This is the engine running under the hood of technology that you probably use every single day. Let's look at a few examples. Have you ever noticed how your search engine just seems to get what you're asking, even if you don't use the perfect keywords? Well, that's semantic search, and it's powered by embeddings. It converts your question into a vector, and instead of just matching words, it finds the documents on the web that are closest to your query on that giant meaning map. And it's the exact same principle behind recommendation engines on Netflix or Amazon. When you watch a sci-fi movie about space travel, the system looks for other movies whose embeddings are neighbors in that sci-fi space travel part of the map. It's not just about tags or genres. It's about finding things that share the same conceptual DNA. And finally, embeddings are absolutely incredible for finding patterns in huge amounts of data, completely automatically. You can feed a model thousands of news articles, and just by clustering their embeddings, it'll group them into topics like technology, sports, and finance, without any human telling it what the topics are. So let's zoom out for the big picture. The crucial point here is that embeddings aren't just one small feature. They are a fundamental building block for how modern AI understands the world. So when you put it all together, what have we learned? Well, at the very center of it all is that one simple, powerful idea. On the meaning map, proximity equals similarity. It's that core principle that allows machines to finally grasp context, which in turn powers everything from smart search engines to the recommendations you see every day. Ultimately, embeddings are the essential translator, the bridge connecting our messy, nuanced human world to the structured, logical world of computers. And that leads us to one final thought. This technique isn't just limited to text. Modern AI systems can create a shared embedding space for text and images, all on the same map. So if we can map all kinds of human data, our language, our pictures, even our audio, into a universal map of meaning, what does that unlock? What new connections will AI be able to find? And what's the next great territory for it to explore?